Hello class, let's do some practice questions for your exam, final exam part B. The first question we are going to do is about significant figures. So what is the correct answer for the following calculation reported using the proper number of significant figures? So when you do a significant number questions, you have to know the answer should be rounded to the same number of significant figures as the least precise measurement. So the next question is, how do you identify the least precise measurement? So if you do a multiplication or a division, you have to find the one with the least number of significant figures and then round off your final answer to that number of significant figures. If you do a addition or a subtraction, you have to find the one with the least number of decimal places. And so remember, in the earlier case, it was the least number of significant figures, and in this case, it's the least number of decimal places. So you are going to find the least number of number with the least number of decimal places and round up your final answer to that number of decimal places. So let's go on to this question. So I'm going to break this into two parts. First is subtraction, and I'm going to solve this part first and then do the division. So if you do the subtraction and you are going to end up with this number, and let's consider these two values. 9.06 have two decimal places because this is a subtraction. We are going to consider the decimal places, and 0.03 has one decimal place. So your final answer should have just one decimal place. So the first part is done, then go to the second part. So we are going to divide 8.8 by 1.760. So when it is a multiplication or division, you have to find the number with least number of significant figures. So this one has two significant figures and this number has four. And we know our final answer has to be in two significant figures. That's why we have 5.0. So the answer to the question is D. Which atom has the largest number of neutrons? So this is a question where you have to know about your mass number and your atomic number. As example, let's say oxygen. This is not relevant to this question, but let's take this as an example. So if you take oxygen, it has a mass number of 16 and atomic number of 8. So you know the atomic number is equal to number of protons and mass number is equal to number of protons plus neutrons. So how do you find number of neutrons? Is you are going to subtract your number of protons by mass number. So you know number of protons is equal to atomic number. So in this question you have given your mass numbers, and let's take A. It is sulfur and it has a mass number of 35. It's given, and you are going to refer to your periodic table and find your atomic number. It's 16, and then mass number minus number of proteins, or your atomic number, is equals to number of neutrons. So the number of neutrons in this case is 19. So you are going to do the rest in a similar fashion. So chlorine has the mass number of 36. It's given an atomic number of 17. This is what you have taken from your periodic table, and you are going to subtract these two numbers, and the answer is 18. And you are going to do the same to potassium, argon, and calcium. And then you see the largest number of neutrons is in argon. So your answer is D. If the following ions shown below are combined, what is the formula of the corresponding ionic compound that is formed? So this is a question that the charges are already given to you. X has 2 plus charge and Y has 3 minus charge. If in any case you have given like elements like let's say oxygen or calcium, so you have to go to your periodic table and figure out what the ionic charge is if it is not given. So in this case charges are given. Now we are going to use the crossover method. So we are going to end up with X3 Y2. The answer is E. What is the empirical formula of a compound containing only carbon and hydrogen atoms if its molecular mass is 32 AMU atomic mass units? So if you have given a molar mass and an empirical formula, so let's break this down one by one. So you are going to get your actual molar mass, which is given 32, and you can calculate your mass of your empirical formula, and you are going to get a ratio. So you get this ratio, and you are going to multiply it by the empirical formula to get your actual molecular formula. So don't get confused now. So you are going to work with your masses first and get the ratio, and you are going to multiply this ratio by your empirical formula to get the molecular formula. So let's go to number A, part A. It is CH3, and empirical formula is the simplest form of your actual formula. So your molecular mass is 32. CH3 has a mass of carbon is 12, hydrogen is 1, so it's 15. 32 over 15 equals 2.13. Let's say it's 2, and then we have this ratio, and then we are going to multiply it, the empirical formula, by 2. That will give you C2H6, and we can calculate what the actual molar mass of this guy. So carbon has 12, that means 2 times 12, 1 times 6, that makes 30. But what we are asked is 32, so this is not our answer. So we go to the next one. So in the first glance, you will understand this is not an empirical formula, because empirical formula is the simplest presentation of an actual formula, C2H8. If you can see, this can further divide into CH4. Let's go with C2H8 because this is what we have given. So actual formula is 32. The C2H8 has mass of 32, and the ratio is 1. So 1 times C2H8 is the C2H8, and we can calculate the mass. Carbon has 12, and then H8 has 8. 12 times 2 plus 8 is 32. However, so let's keep it that mind that we got the correct AMU, but it's not the correct, it's not the empirical formula. So let's go further and find out whether there's a perfect match for this. And the C is C2H6, and we are going to divide 32 by 30, which is the mass of the empirical formula, and we have a ratio of 1. And if we multiply C2H6 by 1, the same answer, and we are going to find the molar mass of C2H6. But we have, it's not a match. So we are going to CH. CH, we are going to get, we do the same thing, and then we have a ratio of 2.5. So when you have a 2.5 ratio, what we are going to do is we are going to make it a full integer. 2.5 times 2 is 5, 2.5 times 2 is 5, and then the molar mass of C5H5 is 65. It's not still 32. Let's go to the last choice, CH4. So CH4 gives you a ratio of 2. That means that will make 2 times CH4, C2H8, and C2H8 has a 32 molecular weight. And this is your perfect answer. So the answer to this question would be E. So let's go to the next question. How many grams of H2O would contain 6 times 10 to the 23 oxygen atoms? So in this case, you have to write down a few data first. So you know 1 mole of H2O contains this much of atoms. This is the Avogadro number of atoms. And 1 mole of H2O also weighs 18 grams. This is you are taking by calculating your molar mass. So let's do a dimensional analysis in here. What we are asked is 6 times 10 to the 23 oxygen atoms. This should be 23 as well as this should be 23. And we know by this data 6.023 times 10 to the 23 oxygen atoms is equal to 1 mole of water. Uh, in 1 mole of water has this much of oxygen atoms, and 1 mole of water is weighs this much of grams. So this atoms cancels out, and let's say this is 1 to 1 and this 2 cancels out. Remember, this is 10 to the 23, 10 to the 23, and what you are going to end up with is 18 grams. The answer is C. In a certain reaction, the experimental yield of carbon dioxide was determined to be this much. The theoretical yield was calculated to be 34. The percent yield. So how do you find the percent yield is you are going to divide actual yield by theoretical yield and multiply by 100%. So the answer to this question is C. Which of the following reactions is not an acid-base reaction? So if acid and base react, they will form a salt and water. So we are going to analyze these reactions one by one and find whether there is a salt and water. So first one, base, acid, salt and water. This is correct. Base, acid, salt and water. This is correct. Base, not acid, uh, it makes a base, and then sodium bromide. This is the salt, but we don't have water here. Acid, base, salt, water. So the not an acid-base reaction is C. So consider the following reaction. Zinc, copper sulfate gives copper, the metal, and zinc sulfate. Which of the statements below is correct? So this is asking which undergoes oxidation and which undergoes reduction, and what makes oxidizing agent and which one is reducing agent. So remember, in this case, oil rig, oxidation is loss, reduction is gain, and we are talking about electrons here. So let's take zinc. This is the metallic zinc. That's why it's identified as solid. And it makes the zinc sulfate in aqueous solution. That means in the aqueous solution, it exists as zinc 2 plus ions, sulfate ions. That means the zinc metallic ion undergoes oxidation to zinc 2 plus because it's a loss of electrons. Metallic zinc got oxidized in this reaction. Yes, so this is the correct answer. And let's think about the copper 2 plus. Here, copper sulfate in aqueous solution. In the aqueous solution, it exists as copper 2 plus and sulfate ions. So copper 2 plus in this side gives off copper metal. So that means it gained electrons. That means a reduction. Copper 2 plus got reduced. So your answer would be D. If 125 ml of this much sulfuric solution must be prepared from a stock solution of this much sulfuric acid, calculate the necessary volume of the stock solution. So you are going to use, because this is the same solution and it's a dilution, you can use this equation C1V1 equals C2M2, and your C1 is your stock solution. It's 6.00 molar, and then your V1, we don't know how much you need to take. That's the question. Calculate the necessary volume of the stock solution. So you're going to find the volume you are going to need, and then your resulting solution is this much of molarity, and then the volume is 125. So your answer to this question is D. A sample of water vapor is kept in a 750 milliliters sealed container. What happens to gas pressure if the whole sample is moved to another sealed container that has a volume of 1.50 liters? That means they doubled the volume. The temperature of the gas is kept constant. So it's important to know the T is constant. So we are going to use the Boyle's law here, and we know P1 V1 equals P2 V2. P1 is we take the uh, pressure of this container as P1, and it's 750 milliliters, and then they are going to double the volume to 1.50 liters, and that's going to be P2. So when you do the P1 V1 P2 V2, you are going to derivatize this reaction, and you are going to take P2 here and V1 goes down, and the ratio is 2 because your V2 is 1.50, V1 is 0.75 liters, and your ratio is 2. That means your P2 equals P1 over 2. In other words, P1 equals 2P2. So this pressure equals twice as this one. In other words, this one has the pressure will decrease by factor of 2. Okay, and this one, in other words, this one has like twice as pressure as this one. So your answer is C. So how many liters of hydrogen are produced from 1.0 mole of aluminum and 3.0 mole HCl as the result of the following reaction? Assume that hydrogen is at standard temperature pressure. So STP means standard temperature pressure. Temperature is 25 degrees and pressure is 180 m. So we are going to use PV equals nRT, and here it says 1 mole of aluminum and 3 moles of HCl. That means then as the stoichiometric ratio indicates, if you react 2 moles of aluminum and 6 moles of HCl, it gives 3 moles of hydrogen. But if you divide these numbers by 2, if you react 1 mole of aluminum with 3 moles of HCl, it should give off 1.5 mole of hydrogen. We divided these numbers by 2. Now we know the number of moles, and we are going to use the ideal gas law, PV equals nRT, and we are going to take the V out, and then that means the P goes down here. So we are going to plug in the numbers and your answer is E. A sample of chlorine gas in sealed 2.50 liter flask kept at 45 degrees Celsius has the pressure of 1.73 atm. How many moles of molecular chlorine are contained in the flask? So we are going to find the number of moles of chlorine. So what we have given is the volume and the temperature. We are going to convert it to Kelvin and the pressure. So we are going to use the PV equals nRT and then just plug in your numbers. And the answer to this question is C. The thermochemical equation for the combustion of ethanol is shown below. And calculate the enthalpy change for the following reaction in in these units. So this is where you apply the Hess's law. And we are going to first look at the reactions really well and identify what they are asking. See, in this reaction, carbon dioxide and water are in the product side. And in this case, what you have to calculate is the reverse of this reaction. See, here carbon dioxide and water, and here your reactants are carbon dioxide and water. First thing you are going to do, flip this reaction. In that way, you are going to get this carbon dioxide and water in your reactant side. If you flip the reaction, you have to flip your sign for the delta H as well. So it is plus now. And then look at this 2CO2. In this, if you flip, you end up with 2 carbon dioxide, but you have to calculate for 6 carbon dioxide. So we are going to multiply this reaction by 3. And if you multiply the reaction by 3, then you have to multiply your delta H by 3 as well. So your answer for this question is A. How much heat in kilojoules is released? When you say released, then you will figure out this is the exothermic reaction and the delta H would be negative. As 10.66 grams of potassium chlorate, this is this guy, decomposes according to the following reaction. So if you look at this equation, you will notice that 2 mole of potassium chlorates gives off this much of kilojoules. And what 1 mole of potassium chlorate weighs 122.55 grams. You get this number by calculating the molar mass of this potassium chlorate KClO3. Now we are going to do a little bit of dimensional analysis. So what we are asked is 10.66 grams. And we know 122.55 grams with 1 mole, and then this gives how many moles of potassium chlorate are in the reaction. And we know from this 2 moles of potassium chlorate gives off this much of heat. So we are going to do the dimensional analysis, and then your answer is 3.69. So it doesn't matter whether you haven't seen minus 3.699 because you asked how much energy is released. So it is an indication this is minus value. So your answer to this question is A. So all of the following sets of quantum numbers are not allowed except, that means there's one set that is allowed. So let's go for it. So let's do part A. N equals number 1, that is your principal quantum number is 1. And if it is 1, you can have L only 0. There's no 1. So we can cross out this in this step. So when you go to B, n equals 5, that means your principal quantum number. You can have L values like 0 to n minus 1. That means L values could be 0, 1, 2, 3, 4. So L equals 4. Yes, it is allowed. And then we are going to next step, ml values. So in L equals 4, ml values minus, yes, we have minus 3. It is good. And then they say ms value is plus 1. So that's a no-no, because ms values cannot be plus 1, because it could be either plus half or minus half. This is a no. So let's go to C. It says n equals 2, that means your principal quantum number. And when it's n equals 2, you can have only two L values, 0 and 1. So here it says L equals 1. Let's go to L equals 1. It can have uh, L equals 1, it can have ml minus 1. Yes, minus 1, 0, plus 1. It is good. And m is plus half. Yes, that's right. And this is correct. So if you want to go ahead and mark this as your answer, or you can analyze D and E as well. Let's analyze D and E as well. Your n equals 3, that means you can have L value 0, 1, 2, and not minus 3. L cannot be minus 3. So, no, this is not the correct answer. E, L equals 4, that means you can have L value 0, 1, 2, 3. When it is 0 in the 0 level, you cannot have a ml of 2. The only ml you can have is 0. So this is not the correct answer as well. So you are going to pick your correct answer as C. So this is the end of the example questions, and I wish you good luck, and please let me know if you have more questions.